So good morning, everyone. I hope you had a nice break. So let me do a little bit of a recall of what we were doing, because it has been, some time. So remember, we actually figured out the consumer's problem, right? We knew, and now we know how to solve it. So basically, what was consumers' objective? What were they trying to do? They were trying to maximize their utility, right? So what they were doing is basically, so they were trying to solve the following problem. So let's call this recall. So, and this is the general version. So you had a utility function, right? So you might have n goods, and then you're looking for the optimal amounts of, right, x1, x2, xn. But you wanted to maximize your utility, but what was your problem? You had a constraint, right? And it was subject to the budget constraint, right? So this is basically the budget constraint, which says that you should not consume more than your income, right? The value of your consumption, your expenditure cannot exceed your income. And then remember, we said due to more is better and such, we can write it like this, right? So we solved this, and how are we solving this? If we had certain conditions, obviously, about the utility function, and we had an interior solution, right, and such. So we were solving this using Lagrangian, right? So we used the Lagrangian, and then we actually solved one example with Cobb-Douglas. Now, actually, so that was example 1. And now think of another example. This would be example 2. Before I give you the utility function, let's actually do this. So basically, suppose you would like to always consume, so let's write this down. Suppose you would like to consume each unit of y with, so as I said, remember, we did the Cobb-Douglas, so the previous example was Cobb-Douglas, okay? And this is another example, but you'll see what that is. So suppose you would like to consume each unit of y with 4 units of, let's say, good y, with 4 units of good x. So with exactly 4 units of good x, let's say, with exactly 4 units of good x, suppose you would like to consume 1 unit of y with exactly 4 units of x. How can we write down this utility function? What do you think these goods are? So you would like to consume each unit of y with 4 units of x. These are complements, right? These are what we call them perfect complements. If there is, it doesn't have to be left shoe, right shoe. It doesn't have to be 1-1 all the time. But it has to be, it could be you would like to have 1 tea with 2 cubes of sugar, right? Or you might have 1 unit of good y with exactly 4 units of good x.
Perfect olmayanı nasıl buldun? Yani böyle tercih ederim de olmasa da olur mu?
So it's sometimes you can call them complements, right? Because they go well together. So there is actually, perfect means that there is absolutely, no way of substituting one for the other, right? So it could be that for you, coffee and tea might be, to some extent, you might like them. You might want to have your coffee first and then your tea. Right, so it could be, to some extent, for some people it could be completely substitutes, but some people might consider them, complements, but they're not perfect complements, right? Like one of them is not completely useless without the other, okay? So that's why, but you're right. I mean, you'll see that in this course we're going to see perfect competition, and in real life there is no perfect competition, okay? So these are all ideal cases. So how am I going to write down this utility function? Suppose your preferences are like this. I would like to write down the utility function, which represents these preferences, right? So for perfect complements, do you remember how were we writing that utility function? What was it for perfect complements? Right, it was minimum, right? So that was this weird function. So we were writing minimum of, okay, how? So they were Leontief, right? So it is, so basically, so this is actually where students, most of the time, they get confused. So guess, give me your guess. So 4y, x. So it's, if we would like to write this, or 4xy. Which one do you think? 4xy, 4yx. So actually, so just from now on, hopefully you won't forget, it's usually, whatever it says here, it's usually the reverse. So it's actually what your friend was saying, so it's x 4y, okay? So because you'll see that if I want to draw the Leontief, right? So this is sort of these indifference curves, they have these L shape. So I'm going to put here x, I'm going to put here y, okay? So this says that, right, so you would like to have 1y, right, with 4 units of x, right? So that's what we said. So basically, it says 1y with 4 units of x. So if you have 4 units of x but more y, it doesn't matter, right? So because these have to be consumed at this perfect rate, okay? And then basically, if you have 1y, and if you have, you know, like let's say 5x, still it doesn't give you any utility, any extra utility. So remember, these are your indifference curves. And if you want to look for the other ones, let's do it at 8, right? Then you would have 2, and this is going to have 8, right? So you would have indifference curves like this, okay? So if you want to write down, you know, like the utility function, which is representing these kind of preferences, then you would see that it is written as minimum x 4y. So it's like, you know, 4 units of x, but that 4 comes to here. But now you'll understand why. Okay, so basically, so these are my indifference curves, u0, u1, fine. Now, remember, this is how we were solving the utility maximization problem, right? We were using Lagrangian. Can we use it here? So suppose we would like to figure out optimal bundle, right? We want to figure out x star, what is x star, y star. Can I use our method, Lagrangian, here? Yes, no, maybe. No, why? Why not? Right, so this is, remember, whenever we said this maximization problem, when we were doing the, you know, like when we write down the Lagrangian, we were taking the derivatives, right? But what are we going to do here? This utility function is not like Cobb-Douglas, right? Cobb-Douglas was nice, so it was something like this: u x y, x to the power alpha, y to the power beta, right? But now here, that was differentiable, right? We could take derivatives there. Here, we cannot take derivatives. So how are we going to solve this problem? So in this case, Lagrangian is not an option, okay? So this is the problem, but we cannot write down the Lagrangian, okay? So what should we do? But remember, you guys told me, a smart consumer would, suppose you have a budget line like this. Let's, I don't know, let's actually have this, suppose, bless you. Suppose you have a budget line, so let's put it like this. So where do you think the consumers would consume? So suppose you have a budget line, let's say like this. So, and suppose we have many indifference curves. Suppose I also have one here. So where do you think a smart consumer would consume here? No. Why not? Because here you're getting this much utility, but you're spending, you know, these excess income on, I don't know, let's suppose this is 1.8, right? So you're spending extra income. It doesn't bring you any utility, right? So where do you think a smart consumer would consume? On these vertices, right? So the optimal point here, of course, he can do better, but probably he would go here, right? Because it's the point where you are consuming enough, y's and enough x's and in the right proportion, right? So that's why, even though we cannot use Lagrangian here, what can we do? We can just use, you see that, remember I told you that sometimes we would have corner solutions, sometimes the utility function might not be differentiable, but still we can solve it by making, arguments. So here, then you would tell me what? Hocam, a smart consumer would be consuming at these kinks, right? At these vertices. So basically, at this vertex, what's happening? So it's actually x is equal to, so if you want to write down, like all the points, the geometric location of these points, you would see that it is actually x is equal to 4y, right? Right, so how can we write down the equation that gives all the points on these vertices? It's basically x equals to 4y, right? Then this is what? We didn't do the Lagrangian, but we actually got a relation between all the optimal x's and all the optimal y's. How did we call this? It was called? Remember when we were solving Cobb-Douglas, we write down the Lagrangian and such. What did we do? Income expansion path. You see here you didn't get it by getting the ratio of the first two first order condition, right? But here you get it by logic, saying that a smart consumer would always consume at the vertex, okay? So this is basically income expansion path. Okay? Now, remember what were we doing with the income expansion path? Yes?
Why are we taking x as 1 and 4y? Like, why are we not taking 4x and y? When the question says, like, consumers consume 1y with 4x.
Okay, so try, you see if this represents, right? So this is 4 x's with 1 y, right? So you're taking minimum of what? You're taking the minimum of, right? So like this is basically y, and so in order to put here 1 and in order to put here 4 so that they would be equal to each other, that's why it's reverse, okay? Is it clear? So this is actually, if you want to write down this, the equation for these sort of like, the utility function which would lead to these type of indifference curves, you see that you need to put, right? So you would always put x for 4, like as 4 and y as 1, right? And you know that at this point, at the optimal point, these should be equal to each other. So here I should be putting 1y, 4x. At the optimal, it should always be the case 1y should be 4x, right? So here, otherwise, if we had done that, then you would do this. 4x, y, you would put here 1, you would put here 4. They won't be equal, okay? That's why we write it like this. That's why it's reverse, okay? Always think of it that, okay, it means that they should be at the vertex, they should be equal. So I should put 1 for y, but there should be a 4 in front of y to make it equal to 4x, right? Because that should be the optimal point all the time, right?
The optimum point, x and y should be equal.
The ratio, the ratio should always be there, okay? So this is called sometimes fixed proportions utility, okay? So that fixed proportion should be there even for the optimal amounts, okay? So this is the only way you can get that, okay? That's why it's reversed. Is it clear? Okay. So now this is the income expansion path. What were we doing afterwards? Do you remember? when we found the income expansion path, what were we doing? We were putting it back to the, so you found the relationship between the optimal x and y. What were you doing? Then you put it back into the budget constraint, try to solve for optimal x and y. So you put this into, so let's put it from here, budget constraint, okay? Put this into budget constraint. So you see that once you figured out to solve the case for perfect complements, it's easy. You don't have to have the Lagrangian. You just be smart and you say that the optimal points should be on the vertices, and then you just, and you know the geometric, you know, the equation which represents these points on the vertices, which is basically this, and then you just put this back into the budget constraint, right? So which is px times, right? Instead of x, I write 4y plus py times y, which is equal to I, right? So from here, I get y 4px, so I take into the y parentheses, py equals to I. So you see that y star I divided by 4px plus py, okay? So this is the demand curve in this case for y, good y. And what were we doing? Then you can put this guy back into this relation. Either you can put it back into here or you can put it back into the budget constraint to solve for x star, okay? So let's do this. X star, so you guys tell me, what is it? 4 times this, I divided by 4px py. Okay, so if you actually do this, x star is going to be, so these 4's cancel out, you have to take this into 4 parentheses as well. It's I divided by px 1 over 4 py. Okay, so you see, once you know how to solve for the case of perfect complements, then that's easy. Okay, so this is the case, so this is the demand curve for y, and this is the demand curve for x. Okay, so you see all these special cases might lead to different stuff. Okay, so now let's actually move on. Now remember, so this was a case where Lagrangian didn't work, right? So which was okay, but we said that we can figure this out by ourselves. Now let's come back to this case, okay? So suppose we have this R problem, okay, which is this. Now suppose I get from these, I get these optimal points, okay? I solve this, I get these optimal points, right? So let's call this x1 star, right? Let's call it x1 star. So x1 star is a function of what? Demand function is a function of what?
P1.
Income and P1 and all the other prices, right? It's a function of all the prices and Pn income, right? And then you have xn star P1, P2, Pn okay? So these guys are called demand functions, okay? So we call them demand functions, okay? Now, demand functions, okay, now what we would have is actually this. Now, remember, suppose we're interested in the maximal utility that you're going to get, right? Then how can you find the maximal utility you would get? What would you do? What is the maximal utility? Remember in calculus, you were finding the maximizer, right? The x which maximizes that function fx. But to find the maximum, value of that function, you put that x star back into the function, right? So if you put these demand functions, okay, back into your utility function, then you would get something like this. U of x1 star, x2 star, right, xn star, right? And then you would, so this would be, I know that x1 star is a function of p1, p2, pn So x2 star, of course, is a function of p1, p2, p and I. And xn star is a function of, again, all the prices, p and I, right? Then this, what we call this value function, right? This function which gives you the maximal utility is also a function of what? Let me call it v, function v. It will be a function of what? Prices and income, right? So it would be a function of prices and income. So we have a special name for this function. Know this from now on, okay? This is called indirect utility function, okay? So this is basically, it's an indirect utility function. It is in, like in calculus, in math, sometimes it's a value function, okay? So these functions, you put the maximal value or minimum value back into the function, and the function which gives you the maximal value or the minimal value is called a value function, okay? And this indirect utility function is a value function, but in, like in the consumer theory context, it has a special name, okay? And why do you think it's indirect? Why do you think it's called indirect? Because, you get utility from what? Do you get utility from prices? No, right? You get utility from what? The goods, right? So that's why, but the goods, the optimal amount of these goods are actually depending on prices and income. So indirectly, it's as if you're getting some utility, okay, from prices and income. That's why it's called indirect utility function, okay? So now let's continue with our examples, and you'll see that why this indirect utility function is very useful and such. So we're going to see examples. But before, let me actually ask you the question again, where we would be basically dealing. So let me ask you, so let's put this on hold for a second. We're going to find the indirect utility function of the perfect complements case, okay, and also for the basically Cobb-Douglas case, okay? But let me ask you this question. So because you'll see that why this indirect utility function would be very useful, okay? So we'll see. Now, but before, in order to see that, let me actually ask you this question. So suppose some of your friends might already, because we talked about it a little bit, so suppose you would like to put a tax. Suppose you guys, I hope you don't, but suppose you guys smoke, okay? Or you guys drink, like whatever you like. But suppose I'm going to put a tax on cigarettes, okay? And suppose you like consuming cigarettes, okay? You like cigarettes. Now, suppose, shall I put this tax, and suppose I'm going to tax every pack of cigarettes. Suppose every pack you consume, I'm going to get 1 Turkish lira as a tax, okay? From every pack. So do you want me to put this tax on on the cigarettes, on the good itself? Or suppose I can compute whatever tax I can get from you, if I put it on every pack of cigarettes. Suppose I'm the government, I compute this. And suppose I said that, well, it doesn't matter for me if I'm going to get the same amount of tax, whether I put it on your income or on, good X, or on cigarettes. Which one you would prefer? Or suppose I'm going to give you guys a subsidy. Suppose you like milk. So for every bottle of milk, suppose I'm going to give you 1 Turkish lira. So if milk is 6 Turkish liras or whatever, you're going to get 5. You can buy it at 5 Turkish liras. Okay, so that 1, I'm going to give it to you. So do you want me to give the subsidy, put this subsidy basically on, milk, or shall I give you how much money I'm going to give you? I should give it to you directly. I should give you extra income. So these are actually very similar, same questions. So would you prefer to be taxed on the good or just get it out of my income? Which one do you think? Some of you would would know, but guess why? So you see that even, so some of you might be, this is usually, like question that we get most of the time when we teach this microtheory course, because you keep hearing stuff on the news, right? Interest rates, right? Monetary policy, central bank. So like you would, and whenever you take like a macro course, you would feel that, oh, these things are much more related to real life and such. But actually that's not correct, okay? So these are, you see, in terms of policy and such, these are very basic and very important questions. For instance, tax. Where should you put the tax? On the good, or I should give them some, right, money? Or I should give them, that's another question, in-kind transfers, aynı yardım. So you would basically give them, remember in the okul sütü kampanyası, right, the milk campaign in the schools, or I should give them, like the milk itself, right? So these are all very important questions. And for instance, with the tools that we have learned, we can actually answer them. So you can even advise, on some policies, you should do it like this. You shouldn't give them, you shouldn't put the tax on the good, but you should actually, you'll see that you should actually put the tax on the income, because people would be happier that way, okay? So we'll see why that is the case, and you see that the tools that we have learned, even though they might look a little bit too, hocam, they looked indifference curve, utility function. So they seemed a little bit not much related to real life, but you'll see that we can, with the help of those, we can actually figure out a lot of stuff, okay? Lots of policies, what we should do and what we shouldn't do, okay? So now, but of course, as we were discussing, like these would work, whatever we would say, it would work under certain assumptions, obviously. Nothing is perfect, right? So, but you should, as long as you keep in mind that, these work under these assumptions, but in this case, these assumptions are not holding. So we might need to come up with different solutions, okay? So that is very important. And that is, you'll see that way of thinking would be very useful and very helpful for you in every single course in economics and even in life, okay? So, when these things happen, this is the result. But if the assumptions are not correct, we might not get it, okay? So let's see. My question, so first I'm going to do this graphically, and then I'm going to do this using indirect utility function. And you'll see that, hocam, with the indirect utility function, life is really, really much easier, okay? But let's actually get this graphically. Now, let's do this. So now this is actually called, so let's see how much time we have. This is called the lump sum principle, okay? So just write this, lump sum principle, okay? Now I'm going to do this. So let's finish this and then let's have the break, okay? So then you'll have your break so that it won't be, okay. So this is going to be, so I'm going to put here y, I'm going to put here x, okay? Now you're going to see your professor's abilities of drawing, which is not very good, but we'll see, okay? But that's why I like to do everything on the board and not use slides, because, if you suffer there, I should be suffering here as well, and that's the best way of learning, okay? So this is, now let's suppose initially, okay, suppose you have this, suppose you have, or let's put it like this. Okay, so I'm going to call this first budget line B0, okay? So what is the slope of this budget line? Minus 1. I didn't write anything. So what is the slope of this budget line? Minus px over py, right? So this is basically, so the slope here is minus px over py, right? And suppose in this case, suppose I have a, we can actually have this here, Doesn't have to be, so let's do it. Wait, don't draw. So it doesn't have to, it can be anywhere, but so let's actually have this, okay? So this is, suppose this is the initial optimal bundle, okay, somewhere here. So I'm going to call this X star, and I'm going to call this Y star, okay? Now, and let me call this first initial case E0, okay? So suppose initially, okay, the budget line, we have this budget line, the budget constraint is B0, okay? And what is this budget constraint? If I want to write this, Px times X, right? Plus Py times Y equals to I, right? So initially, suppose we're at point E0, and initially optimal bundle is X star, Y star, okay? Now, let me introduce a tax, okay? So let me introduce the tax. Suppose this is, if you want, this is, you know, good X is, let's say, cigarettes or whatever, okay? Now, consumers, so this is the case. Now, you introduce a tax, okay? Suppose every unit of X, you are actually going to put a tax of T Turkish liras, okay? It could be 1, whatever, okay? So now, what is the, and suppose, so how would the budget line change? So now, initially, price of X was Px. Now, price of X, let's call this Px tilde. Price of X will be what? Px plus T, right? So it's going to be Px plus T, right? Now, okay, so this is the case. So now what happened? Price of X has increased, right, due to the tax. Now, how would your budget line change? So it's going to, right, move. So is it going to shift parallel, or it's going to rotate? Is it going to rotate inwards, outwards? Right, so it's going to, because now it's more expensive, your budget set will be smaller, right? So let's actually do this. So this is going to be, okay, so I'm going to call this B, so I'm going to call this budget line B1, okay? And then suppose suppose we have a point like this, okay? So let me call this U0, let me call this U1, okay? And I'm going to call this E1, okay? So this would be Y1, X1, okay? Now let me write this. This is the new price. So the new budget line is B1, which is, tell me the equation of this new budget line. Right, so Px plus T, or Px tilde, because now it's the new price of X, right, times X plus Py times Y, which is equal to I, right? Consumer's income didn't change, right? Now, and we said that the optimal bundle in this case is what? X1, Y1, okay? Now, from here, there's a tax. So what could happen is actually this, right? So you put the tax on X, so this is actually what this guy is doing. Okay, now, suppose the government they're willing to, they say that, well, if I collect the same amount of tax, either from, you know, like for every unit of the good, I'm going to get T Turkish liras. So how much money government would collect here if they're going to get T Turkish liras from every unit of cigarettes that you consume, for instance? T times X1, right? So here, government is going to tax collection, let's put it, T times X1, okay? Suppose government says that, okay, I'm going to get this T times X1, let's say it's 100 Turkish liras, I'm going to get it from your income. So let's see. Okay, let's see what's going to happen. So let me put it on your income. What's going to happen? Tell me the budget constraint. I'm not going to put the tax on the price of the good, but instead I'm going to get it from your income. Okay, I'm going to tell you, give me this much money. Okay, now what would be the new budget constraint? So let's call this B3. Okay, so this is the case with the tax. Suppose, so this is the third case, suppose no tax on good X, but T times X1 TL tax on income. So tell me the budget constraint. Let's call it B3. What would be the slope of that budget constraint?
The same.
Px over Py, right? Because the government said that I'm not going to put the tax on good X, right? I'm not going to deal with the prices. I leave the prices as they are, but I'm going to tax your income, okay? So then B3 is what? So Px times X, Py times Y equals to what? Equals to I minus, right? T X1. So let's call this I prime, okay? So this new income level. Okay, now I want to draw this. Where do you think, I know that it's going to be parallel to which one? B0 or B1? B0, it will be parallel to B0, right? But where do you think it would pass? So the crucial question here is, you see that, do you think it's going to pass through this point? So it will be parallel, but do you think when it's parallel, it's going to be actually, so it will be parallel something like this, right? But do you think it's going to pass through E1? Yes, no, maybe.
Yes.
So, you know, that is the beauty of math. We can figure this out. And you see that it's math, but it's going to tell us a lot. So it will, okay? So let's try to figure that out. So you see that because X1 and Y1 are on B1, right? So this is the question. So let me write down the question. Question, okay? B3 goes through E1. We don't know, but let's see. So what do I know? That X1, Y1 is on B1, right? So then it should satisfy that budget constraint, right? So then what can I write? So let's say this. Since X1, Y1 is on the budget constraint, we called it B1, right? I can write Px times X1, Py, is it? What is B1? Am I writing it correctly? No, right? So it shouldn't be Px, it should be Px plus T. Px plus T times X1, Py, Y1 equals to I, right? So I know that X1, because this point is on this line, it should satisfy its equation, right? So this is the case. So what does that mean? It means that Px times X1, T times X1, Py times Y1 is equal to I. So if I write this, Px X1, Py Y1 equals to I minus T times X1, which is equal to I prime. You see X1, Y1 point also satisfies B3, right? So apparently that's the, that's how we can say this. Then this budget line, when they tax your income, is going to be parallel to this B0, and it's going to go through this E1, okay? Now let me draw this. That's where you're going to see my skills, which I'm just kidding. Hopefully I can, pull this. So this is going to be parallel, okay? But it goes through this point. So it's parallel to this guy, but it goes through E1, okay? Even though you suppose like me, you might not have great skills, okay? So then you might mess up, but you see that with math, you can always make this argument, okay? So what do you see? Apparently if I tax your income, so this is going to be B3, you would be on this budget line, right? You can be on this budget line. Do you think it's better or not? So the utility maximization point might be somewhere here, right? So let's call this U2, but I'm going to give you this link, U0, U2, U1, okay? Why did I call this B3? I should call it B2. Okay, so let's call this B2. I don't know why I jumped to 3, okay? So you see that this is B2. So the optimal point, of course, remember, given that the fact that you like that good, you would like to consume that good, because otherwise things might go in different directions. Again, we can always figure these. So you see that this is E2 and we would be at some point. Do you think, so consumers, remember, one, I have the black case that you were taxed on the good, and here I have the red case. So which case do you think the consumer would prefer? The red case, right? Where they are taxed on their income. You see? Because you see that this way they can be on a little bit of a higher indifference curve, okay? So we showed it with a graph. Now we'll give a break and then we'll show it using the utility function, okay? Indirect utility functions. But why do you think this is the case? Why do you think when they tax your income? Yeah, so it's you'll see that you see what's happening here. When they put a tax, what happens? They're going to decrease your purchasing power, right? You cannot buy as much as before. So this is bad, one thing. But so this happens when they tax your income as well. But when they play with the prices, they also artificially distort your choices. Maybe you like X a lot, right? So what is going to happen that if they tax your income, they're going to, but you see that suppose you would like to consume this much X. So let's call this, I don't know, X2, okay? X2, Y1, okay, sorry, Y2. So you see that here you kind of pay, suppose you wanted to consume X2, but if they tax the good, you cannot, and they actually, like they tax basically this X1 and you would be consuming X1, right? So what happens here when they, like tax on your income, you kind of pay the tax with consuming X1 at this high price, right? Up to this point, but you have the option of consuming more X with the lower price, right? If they tax your income. But if they tax the good, every unit of X is expensive, right? So we'll see, so think about it. So we'll see it actually using the indirect utility functions, okay, in next class.